because it is decreasing. So formula B is A equals P 1 minus R to the power of T. So in this formula, our starting value of the car was $35,000. The interest rate, this was the biggest mistake, is converting that to a decimal. So 5% as a decimal, thank you, would be 0.05. And T is how much time passes between the years 2025 and 2030. So how much time passes between 2030 and 2025? Ariana, there's a new homework in that blue chair. So how much time passed between 2030 and 2025? 5. Good. All right, so when we type it in our calculator, we should have 35,000. 1 minus 0.05 to the power of 5. Can I steal your answer? Let me see what you got. You didn't do it? Oh, sorry. Did you do it? Let me see. Okay. Oh, yours is, oh, you left off a 0. It's 35,000. Okay, so 3, 5, 1, 2, 3, 0. 1 minus oops. 5. All right, so you should get 27,000. And then it's $82 and about 33 cents. That would be my answer. Okay. Any questions? I think you all doing pretty good with the word problems. I honestly feel like Module 5, the only problem we're going to have is solving the exponential equations. And we're going to really practice that a lot. We're going to practice it a little bit today, and we're also going to practice it next week. All right, so go ahead and go to page 15 in your notes. So if it has the same first difference, that is a linear function. If it has the same second difference, that is quadratic. Oh, they don't have them? Oh, you can just here. Take it away. All right. Writing it, okay. And if it's exponential, okay, we write that when we have a constant, which just means the same multiplier. So that's if we are multiplying by the same number, we call that a exponential function. So when we're writing an equation from the table, that's the fifth formula. That's formula E that I wrote on the board. There's two numbers. We have A, which is your starting Y value. All right, and if you're looking at a graph, it's the y-intercept. So we started the equation with the A, which is our starting Y value. And B, that's our multiplier. Or in other words, the number we are multiplying by. That's what that means. The multiplier is whatever number we're multiplying by. The number we are multiplying the Y value by. That's what that multiplier is. Okay, so we're going to practice looking at a couple tables. Okay, we're going to write a function rule for the table. Again, our focus will be on exponentials only, which is why you're cutting numbers 1 and 2 in homework 4. So let's go ahead. We're going to skip down to question 3. So your first number in the table, and it's really important that you remember, x has to be 0. All right. So the first y value in my table is 3. So that means that a is equal to 3. Now, don't say it out loud, but you need to figure out what number we multiply by 3 to get 18. And it's the same number that we multiply by 18 to get 108. What number do we multiply by 108 to get 648? They should all be the same number. So you shouldn't have different multipliers. It should be the same number. So take a minute, see if you can figure out what the b value is, and just give me a thumbs up when you know it. So we just got to figure out the number we're multiplying by. Anybody want to volunteer what they got? 6. Anybody else get 6? All right, so that means my b value is 6. And remember, this is how we write our exponential equation. It's y, and it's a, and I usually put b in parentheses to the power of x. So when I write my equation, it will be y equals 3. I'm going to put the 6 in parentheses, and this is an exponent. Exponential functions have an exponent that is x. All right, do number 4 by yourself. So you got to figure out the number that we multiply by 15 to get 75. It has to be the same number that we multiply by 75 to get to 375. So, and the same number to go from 3. So it's always the same number. So the multiplier doesn't change. That's what constant means. So it's not like we multiply by 4 and then we change it to 3 and then we change it back to 4. No, it has to be the same number over and over again. So what is our multiplier? Well, first of all, what is a? The first number is what? 15. So I'm going to start my equation. So this is my a. So when I start my equation, it's y equals 15. All right, what's the number I'm multiplying by over and over again? 5. Anybody else get 5? So, and if you struggle, okay, one thing that you can do to figure out the multiplier, if you can't find it, to find that b value, just take the second number and divide it by the first number. So if you can't figure it out, to find the b value for the second one, if you take 75 and divide it by 15, you will get 5. So that's another way to do it if you struggle figuring out the number. So 75 divided by 15 is 5. So I know my multiplier is 5. Any questions? All right, let's look at a couple of graphs quickly. Let's go to, oh, sorry, we're not doing this page. Go to the graph. The graph on page 16. All right, so we got to look at a table. This table is talking about the value of a car, okay? When we look at the y-axis, I want you to notice that this is the value in thousands. So this 6 represents 6,000. The 10 is 10,000, okay? And when you look at it, everybody look at the screen, what is my red dot doing? Is it going up or down? Down. So that tells me this is a decreasing function, which means it is a decay graph, exponential decay. We know it's not linear because if it was linear, the line would be straight. This is what a linear graph would look like. It's a straight line. And if it was a quadratic, it would look more like a smile, something like that. So this graph, going back to the beginning of chapter 5, this is an exponential graph. And it looks like the asymptote is here at about 3. So this is an exponential decay graph. That's what kind of function this would be. Now, the starting value of the car, okay, that is the same thing as asking for your y-intercept. That's what that's saying. The starting value, if it's a graph, that's your y-intercept. And when I look at this, it looks to me like it's about 12. So that means that the starting value of my car is not $12, right? We can't buy a car for $12. It's 12 what? $12,000. That's the starting value. Now it says, in what year will the car have a value of 4,000? So what this is asking for, in an ordered pair, it's asking me for the x value. What is the x value when y is 4,000? And 4,000 is the same as 4. So when I take, looking at this graph, here's 4. I'm going to trace it over until I hit the graph. When I hit the graph, which is about here, I'm going to go down to see what is that y value. And the y value would be what? 7. Okay, so it's going to take 7 years. So in 7 years, the car is worth $4,000. That's what that's saying. All right, go ahead and do number 8 by yourself. And then we'll go through it together. Yep. If it's increasing, it's growth. If it's going down, it's decay. Still got a code. Just don't want to go away. So this is another exponential graph. You got to figure out if it's going up, that would be growth. If it's going down, it's decay. How many coffee shops were open in 1992? And because this says since 1992, again, this is asking for your y-intercept. In other words, what was the first y value? All right, so I'll give you a second to answer those, and then we'll go through them together. Not a lot. Let me look at it. I got an SAT book. Did they give you one? Like a SAT practice book? We're going to start doing more practice in it. That's what the magic school is supposed to be for, too.
I keep seeing it on homework and on the packets.
Oh, yeah. We're doing factoring all semester because the very last chapter in May is a lot of factoring. So we're going to practice all the way up until May. So hopefully when we get to May, we'll be pros. Okay, so A, increasing or decreasing? What did you pick? Increasing. So when you see, if you look at the screen and you see how I'm tracing the graph from here to here, you notice that my red dot is going up now. So this is an increasing function, which would be exponential growth. Now, in 1992, we started with 400 stores. I always wonder if this is about Starbucks, but we don't know. All right, so here's a tricky question. How many shops were open in the year 2000? So the first thing you need to figure out is what is the X value. So what is the X value will be 2000 minus my starting year, which is 1992. So when you subtract 2000, if you take 2000 minus 192, what do you get? Year 8. All right, so now I'm going to look at my graph. Starting at my X equals 8, I'm going to trace all the way up to the graph. And it looks like it hits it right there. And then I'm going to trace that over to the y-axis, and I get 2,400. So in 2000, there were 2,400 stores. All right, any questions? Pretty simple, right? Chapter 5, historically, has been one of the easiest tests of the semester. So I really feel like, especially if you didn't get the grade you wanted the one we took for Module 4B, this is your chance to redeem yourself and pull your grades up high. All right, so really quickly, can you write on your paper the homework that you just picked up? That is due on Tuesday, February 10th. But what I want to do now, though, because I think homework 3 is the hardest. If you haven't turned it in yet, which I've already put in the grades, homework 3 is due today, right? No, it's not. I'm lying. Homework 2 is due today. Homework 2 is due today. But I want to look at homework 3. So let's go ahead and look at homework 3 because I think this is going to be the hardest part. Oh, this is homework 2. Sorry, let's look at homework 2. Don't listen to me. Homework 2, which is due today. Okay, there we go. Everybody take out homework 2 if you haven't turned it in yet. I think I had a couple people turn it in. But let's look at homework 2 together. And I want to look at these questions because this will probably be the hardest questions on the test. I think the graphing will be easy for you. The word problems are easy. Writing an equation from the table, easy. Interpreting a graph, easy. Equations, a little bit more challenging. All right. So we already started. Which one did we do? 4? All right. So again, for 1, we already have the same base. So you're just setting that equal to each other. All right. I'm not going to solve it, but that's that. All right. Let's look at number 2. These numbers have to be the same, right? They're not the same. So we cannot cross it out. So what we need to do with your calculator, figure out what is my exponent. What exponent do I put on a 9? 9 to the what power is 81? Don't say it out loud when you find it. So is it 9 to the first? Is it 9 to the second? Is it 9 to the third? Show me with your fingers when you figure it out. What is my exponent? What exponent do I put on a base 9? Did everybody get 2? We got 2. So I'm going to change that 81 to 9 squared. Now this doesn't go away though. So I'm going to bring that down and put it in parentheses. Got to put it in parentheses. Now we have the same base, so we can cross it out. So what you have is 8x minus 4 equals 2 times 3x plus 6. Go ahead and distribute the 2. And you should get 6x plus 18. Go ahead and solve it from there. That is the key. You have to figure out what that number is. Okay? Is there another question that you want me to look at? Yes.
So you distributed 2 and 6, is that 18?
You right. You know, I was just playing with you though. This is like actually being a good teacher, is to put the wrong number up there to make sure you all know how to do it. So what should it be? 12. You are absolutely right. Okay. All right. Any other questions? We already did 4. Is there one that you think looks a little hard? Let me see the back. Oh, I don't have the back. Sorry. Thought I did. All right. Use this time wisely. You have all of your homework assignments. Get as many of them done and turned in today as possible. 2, if you already finished 2, work on 3. If you already finished 3, do 4. Everybody should be working on a homework assignment. This is not the time to be sitting on our phones. We got work to do because we have another test coming up and I want us to do very well.